in this quick video, we're going to go over this problem here. Now, if a question is about sine or cosine graph, the very first thing I do is draw a sketch. So let's do this now. If we take the picture we've got here and let's analyse. We always know that in this course we can analyse a cosine or sine graph in terms of A, which is the number in front of the sine or the cosine, B, which is the number in front of the function we're dealing with, and we're going to call this last number D. So I would recommend you always first of all analyse what A is, then D, and then finally we're going to analyse what B means. So A quite aptly means the amplitude. So I'm going to draw a brief sketch with the assumption that our graph is to do with 15 cos. So what we've got to think about is the normal cos graph. If we go into y equals and we type in cos of x, you can see what the normal cos graph looks like. We need to make sure we change our window. Let's change this so it's between -5 and 5. And obviously we've got too much x. So the y should actually be between -5 and 5, and the x, let's say that's going to be between -720 and 720. The reason why I've chosen -5 and 5 will become quite clear now. You can see this is the normal cosine graph. And if you move the cursor around on this cosine graph, you can see that the minimum of a normal cosine graph with just cos x or sine x is always going to be roughly or exactly -1, and the maximum is always going to be +1. So if we've got 15 cos, what do you think is going to happen? Well done. Clearly, if we've got 15 cos, it's going to change it so that instead of varying between 1 and -1, it's going to vary between 15 and -15. So let's copy it from here. So it's going to be the same sort of pattern, etc. So now we're going to have it between 15 and -15. But this question is about a clock. Now, a clock hand cannot go below the floor. That won't happen. And we're going to imagine that this x-axis is the floor. We've got to study now what D is to do with. D tells us the vertical shift. So because it's 150, we're going to move the maximum so it's 150 bigger and the minimum so it's 150 bigger. This means that the clock won't go below the floor, so we can move the x-axis to below the graph. And we need to change the minimum and the maximum and make them both 150 bigger. So if we make 15 150 bigger, it's going to be 165. And if we make -15 150 bigger, it's going to be 135. And you can see that the amplitude still works because the amplitude represents the distance from the middle of the graph to the maximum, which is 15, or the middle of the graph to the lowest point of the graph, which is also 15. So the amplitude is correct. We've also got the vertical shift is correct. And last but not least, we've got to analyse what B means. Now, B is the most difficult. D, like we said, is the vertical. Now, B, we have to do an equation. So we take 360 and then we divide by what B is. B is going to be 6, which equals 60. And this means we expect a whole period to occur in 60 degrees. Now, all these facts will help you with your window on your graph, but actually A and D are the most important. This means that when we put this in our graph, we need to think about these numbers and go for something slightly bigger and slightly smaller. Let's do that now. So if we go onto our graph and we are going to type in our function as you'd expect. So on y equals, I'm going to type the following. 15 cos 6x, obviously we've got to press the X button, not the T button, but it's thought of as the same thing, plus 150. And you can see here I've made a mistake. Maybe pause the video and see what mistake I've made. Hopefully you've realised that we should close the bracket after 6x. So I'm going to delete a few of the numbers. And another way of doing that is just to close bracket here and then delete the ones after it. And then we're going to put plus 150. Then we're going to press graph. Now, as you've thought of before, we're not going to be able to see the graph straight away. You can see here I've also included a plus, which is not correct. So we're going to delete that plus. So when we have a look at the graph, we're not going to be able to see it because we haven't got the window correct. So what we need to do is go onto the window and we need to make sure our y is between roughly 135 and 165. So I go to the y min and I'm going to make that, say, 130, and then the y max, and I'm going to make that 170. And then I'm going to press graph and see if it works. Perfect. We can see a lot more. You can also see that perhaps I can see too much x because it's quite hard to see what's going on. So I'm going to really minimize the x because it really wants us to see probably what's happening for x positive. And this is normally the case. So we're going to go into the window, and on the window we're going to change it so it's between, let's go for 0 and 720. That looks a lot better now. And one other thing you need to check is whether your calculator is in the correct mode. So if you click mode, we want to make sure it's in degree mode, which it is. So let's have a go at the questions. Find the length of the minute hand. So the length of the minute hand is going to be the distance between is going to be to do with this diagram. So let's imagine that when the clock starts at 12, the tip of the handle of this hand is going to be 165 centimetres above the ground, because this x-axis is the ground and this is going to represent the movement of the minute handle. So as the minute handle goes round, it's going to get closer and closer to the ground. And then at some point, it's going to be only 135 centimetres from the ground. And that's because when it goes round here at the number 6, it's going to be at its lowest point. And then it's going to return back to its original position. So we know the period occurs in 60 because it's 60 minutes for this hand to go round. Now, we can use either the x or the y axes to tell us the answer to B. Find the length of the minute hand. What we'd have to do for this is study the 165 and the 135. So we know that at the beginning, at 12, when the handle's at 12, it's going to have a height of 165. And then at 6, it's going to have a height of 135. So we can see that the distance of 30 centimetres is going to represent the diameter of the circle. However, we just want the radius. So we're going to say that the length of the minute hand is half the diameter, giving us 15 centimetres. Wow, that was quite a challenging question. Well done for listening. Find rounded to one decimal place the height of the minute hand's tip at each of these times. Okay, we've decided that the y-axis is the height. So let's label that with the heights, just so we remember. And we know that the x-axis is the time, because in the function it's to do with t, which is the time. And actually we can label this a bit more specifically and call it h of t, which means the height as time varies. Now we've got to find out what happens at 5:08. Now you've got to think, out of 60 minutes, what happens at 5:08? Well, hopefully you can see that this is going to be 8 minutes, or when x is 8. So I'm going to change my window a little bit more. Now I understand exactly what the problem is about. This is because with this particular problem here, what we've done is we've changed the window based upon the period being 360, but we actually want the period to be just 60. So I might just do 2 periods. So I'm going to say x starts at 0, because it often does with these kind of problems, and we want 2 lots of 60, which is going to represent 2 hours, or the clock handle going around twice. Then we're going to press graph. There we go. So we're going to say clock handle at 12, clock handle at 6, at 12, at 6, at 12. So that's 2 periods. Then what we need to do now is find out what happens at 8 minutes past. And this is when the question is becoming quite easy. With this, we need to find what happens when x equals 8, x equals 37, x equals 51, and then we're going to find it for the next problem as well. So let's do 508. At 508, we're going to press second calc, and we want to find a value. So if you want to find a specific x value, press number 1. And we want to find when x is 8. So we press enter, and when x is 8, y is 160. Let's add to our diagram. This means when we've got 8, obviously the hand is going to be a little bit lower than 165, and it's going to now be just 160 meters from the ground, because it's just moved around a little bit, and you can see it's going to be a little bit lower than being at the 12. Let's have a look at the next question. 537. Now pause the video and think what you think is going to happen. Is it going to be closer to 135 or closer to 165? So again, we're going to press second calc, value, this time 37. We can see at this point it's going to be 138.85283 meters, or to 3 significant figures, 139. 551, exactly the same process. We're going to press second calc, value 51, then we're going to press enter. It's going to be 158.8, or 159 to the nearest 3 significant figures. 623. Now, what you could do is you could bear in mind 623 is going to be 83 minutes after 5 o'clock, so you could put it in 83, or you can just realise that the period repeats itself again, so you could either write 23 or 83. What we're going to do then is press second calc. I'm going to show you that 23 and 83 are the same. So 23 is going to give us the answer of 139. And let's have a look at 83. Again, 139. So you can see they're going to be in exactly the same positions, because after every hour, this clock is just going to behave in the same manner.